Okay, so I think we are ready to start. So thank you very much for joining the fourth and final webinar or capacity building webinar of the SPACE4Cities project. This session today is focused around mobility and emissions. This SPACE4Cities project is funded by the European Union Agency for the Space Program. My name is Alex Gluhak. I'm a part of the project, and I represent Open and Smart Cities, which is a project partner, and which is a city network of 170 cities working together on digitizing together, basically implementing interoperable solutions and also guidance for interoperable solutions, so cities can better adopt new digital solutions. Within this project, we explore new solutions enabled by European satellite technologies and data. SPACE4Cities itself is really a new initiative called a pre-commercial procurement initiative, which hopes to bring these innovations to you together. And obviously, the webinar itself is really about for you to learn about what new space-enabled technologies are available, specifically around mobility emissions. You will get early access to ideas and solutions which are currently being developed with the partners on this call as well. So some of the experts that are with us will sort of share insights about how they go about and what they are doing exactly. And also, if you are another city or another region, you have a chance as well to get a preview of what is coming in terms of real implementations, and you might consider even joining us later as part of a replicator in the pilot phase of the project. Good, just a few words about SPACE4Cities. So really, what the challenge that we set is we've got this capability offered now by the European Space Program. These are like innovative satellite services that produce a lot of data, but how can this data really provide value for cities and communities to better manage public areas, green spaces, transport infrastructure, or maintain the city? And overall, we hope those solutions and this that this data enables can make our cities more sustainable and also more resilient. The project itself consists of 7 different partners. 5 of them, they're called buyer cities. So these are real cities who would like to procure those solutions and pilot in the end. This is Helsinki, Amsterdam, Ghent, Guimarães, and also the region of Africa or Athens. And we've got other partners such as Open and Smart Cities, with whom I work, and Aerospace Cities to support with the wider outreach and find also the right sort of delivery partners and the right also pilot partners to join in. Overall, we envision also that the 5 cities in the end will be joined by 10 other cities who will act as replicator of those solutions. We are currently in the sort of phase 1 of the project. So last year we've developed detailed requirements of sort of and problems and challenges that we would like to see addressed by those solutions. And not too long ago, maybe a month ago, we selected actually from 140 applications, 20 solution suppliers that we now work with together to develop a more detailed design of a solution that addresses these challenges. And today's 5 presenters are 5 of those providers who will then share what they do in the context of mobility emissions with us. Obviously, the talks basically focus around their sort of innovative product and service offering, which is around greenhouse emission tracking, how to do better as zoning sustainability assessments, how to improve generally urban mobility and planning, and also how to improve energy consumptions in an urban context. So it's a diverse sort of set of applications that you will have pleasure to listen to. We've got our speakers here from 5 different organizations. Unfortunately, the first two are have last minute been replaced by others. So Mathieu will not speak, but it will be Say from EverImpact. Maybe Say, you can turn on your camera now so people can see you. Likewise, we will have Otso representing Petya from Avoin. Otso, the same here, if you sort of just set your camera live. We've got David from ORG, so this is as expected, David. We've got Jeroen from Geo Solutions. Again, Jeroen, maybe if you can turn on your cam, that would be great. And we've got also Roland from Paulinyi and Partners Innovations. Okay, so yeah, so thanks, welcome to the panel, and looking forward to the presentations that you will share in a minute. So before we kind of start, there's a few housekeeping rules. Please, obviously, if you're not a presenter or speaker, turn off your mic and also turn off your camera so we can fully focus our attention on the presenter. Also, you can obviously use the chat window to ask questions if you want, or submit questions, or interact with the panel participants or with other participants in this room. Please note, however, that you will not be able to ask questions directly to speakers, but you will have to wait for the panel for this, okay? But as you're thinking about your questions after or during a presentation, please post them just into the chat box. We'll pick them up later. And then obviously there will be opportunity also then to join in those panel conversations actively if you wish, okay? So yeah, I think that's all from my end. And I think without further ado, I can hand over to Say from EverImpact to take us through what you guys are up to. Thank you.
Up. Everyone can hear me? Perfect. Good. Okay. So hi, everyone. It's a pleasure to do this presentation today. And today I will talk about EverImpact and the amazing job that we do to, let's say, move cities toward the path to net zero. So let's start. Let's imagine together a future where every ton of CO2 has a name, a unique identifier, a location, a timestamp, a future where we can measure and know precisely, instantly our impact. This future is not a far-off dream. It is actually EverImpact's goal, which is currently building the first ever worldwide CO2 emission registry based and relying on real-time GHG emission tracking. And why is that so? Because we have this deep conviction that it will unlock green and carbon finance opportunities to cities and accelerate them toward net zero. EverImpact has been built in 2015, founded by 3 ex-executive United Nations individuals who has built important systems like the first UN satellite agency, UNOSAT. We are a robust team of 15 professionals, including data and AI engineers, tech managers from Airbus or Google, even data scientists. And we have 3 offices, one in Paris, one in Copenhagen, and one in Tokyo. We are backed by the European Commission financially, by other VCs like Mitsubishi, Capital, and Molplus. We are trusted by industry leaders in three of our main verticals. The first one is the maritime, where we have deployed the first ever DNV certified continuous emission monitoring system to measure CO2 emission from ships, maritime transport. We have also partnered with big corporates like Hitachi in Japan, where we are delivering improved forest management projects and unlocking carbon finance for forest manager in Japan. And of course, today I'm here to talk about the future of our cities, mainly on urban mobility and logistics. So let's be honest. Let's be honest between each other. we know that current estimation-based emission reporting methods are failing. The reason why it is failing is because they face a huge gap in terms of data accuracy, timeliness, and local context. Cities can't really measure the impact of their policy. And therefore, they are missing out by this lack is preventing them to assess baseline and to measure the impact, as I said. So they are missing out huge green funding opportunities because of this bad data. So what do we need to unlock those green finance opportunities? What we need is a direct measurement method at scale, a system that actually sees reality, that is capable to track each ton of CO2 that is emitted on a specific territory, that is able to geolocalize those tons of CO2 at a resolution, high resolution, something around 100 meters, updated every hour. This is when we are going to be able to do these kind of things, that cities are going to be able to allocate CO2 emission ownership to different ground activities like transport, industry, agriculture, residential, etc., etc. So cities will be able to move from accounting tricks to ground truth. And this is exactly the kind of product that we are building at EverImpact. A carbon emission intelligence platform that relies on the most accurate, real-time, and hybrid CO2 monitoring system in the world. How do we do it? We combine data from ground sensors with data from satellite constellations. This hybrid approach, powered by a sophisticated AI model, gives us a complete picture of your city's emissions. It is up to 50% more accurate than traditional inventory methodologies. At the end of the day, it just tracks each ton of CO2 released in your city. So what you're seeing here is no more a model based on 3 years old few bills. This is actually your city's carbon footprint right now. You can see emissions with a resolution of 100 meters updated every hour. You can see the breakdown by sector. You can finally establish a reliable baseline and see the real-time impact of your decarbonization policies. Want you know if that low emission zone is working? You will know next week, not in 3 years. This is the tool that allows you to make data-driven decisions with confidence. And the benefits are transformative. Traditional GHG inventories are slow and expensive, costing up to €8,000 a month for data that is years out of date. Our system provides data every 10 minutes for a fraction of that cost. This isn't just about saving money, it's about getting an edge. It's about having the credible, certified data you need to accept green bonds, carbon finance products, and even just optimize your carbon taxation. And we are not just starting. We have already deployed more than 100 sensors across London, Birmingham, Orléans, Dijon, and even on ships. We have invested on remote sensing instrument that is ready to be integrated into CubeSat to be launched into space. We have invested 7 years of R&D delivering high precision, low cost sensors. And we are now increasing the usage of AI model to reduce the hardware needs and to accelerate the deployment and the replicability of the solution. We have already worked with 14 cities to support them in their climate plan. For example, we have made Dijon the first city in the world to track live CO2 emissions by deploying 75 sensors. We have partnered with British Telecom in the UK's to install sensors in the urban furnitures, what they call their smart street hubs, to monitor CO2 levels in the earth of urban environments. And we are trusted by industry leaders and public institutions because our system delivers. And that brings me to why I'm really here today. Obviously, thanks to SPACE4Cities program, which allows us to refine our current system in order to scale the solution. Deliver real-time high-resolution CO2 data for cities and support LEZ enforcement, public space management, and mobility planning. As part of that program, we are looking for partners, visionaries, leaders who want to be at the forefront of this new paradigm. We are launching a city partnership program for a limited number of early adopter cities. We will provide our sensors completely free of charge. You simply pay for the software subscription that gives you access to this powerful intelligence. We cover the cost of the hardware. Let me conclude by saying that it is too late to be pessimistic to achieve net zero. It is actually the perfect time to accelerate your city's decarbonization. Our sensors are ready. Our platform is proven, certified. They are just looking for adopting cities. So let's stop estimating and start measuring. Let's build a net zero future together. Thank you.
So thank you, Say. So yeah, perfect. So you kept well on time. Can I ask now our second speaker also to come in and to share a bit more about what you guys are doing with zone impact mapping? Okay, so if you want to share your screen, I can see myself.
Yes.
Perfect. Yeah, now I can see the slides. Yeah, better.
Yeah. Hello, everybody. My name is Otso. I'm from Avoin Map from Finland, Porvoo city, nearby Helsinki, our capital. And I'm presenting you zoning impact mapper solution. And shortly about Avoin Map, we are European Space Agency business incubator alumni company since 2021, and we have been developing satellite-based algorithms to scale our map services. And shortly, key expertise, we have remote sensing, machine learning, AI, especially this new foundation model is now revolutionizing the geospatial AI, so we work on that. Environmental and socioeconomic modeling, service design, very important, so we get user-friendly map solutions, and software engineering, some modern software, and mainly we do web software, but everything is possible based on the needs of cities. And some key team members, it's me, the CEO, Lara Yasim, design lead, Petja Valkama, our technical officer, and we work with various scientists, including Andrea Naschetti, who is one of the researchers around this foundation AI model. He comes from Sweden and he's an Italian remote sensing specialist. And now about the solution that we are working on. You can see our prototype applied in Finland on the right side, just in the prototype phase, but you can see how it calculates climate impacts of zoning areas. And the problem here is that urban planning teams across Europe are under pressure to include like climate metrics, biodiversity metrics, citizen well-being metrics in the land use decisions. They are lacking like a transparent, comparable tool so that cities can measure these things on the same methods and as easy as possible and save some time and money. And solution is we are building this Avoin Map zoning impact mapper solution so that you have a web platform that enables in inputting any of your zoning plans or drawing a new plan and getting those numbers based on local and national soil and vegetation data, but also satellite data, scaling it for the whole nation and larger areas, because not always the local data is available. So then you need machine learning and satellite data provided by the European Union. And yeah, on the right side, you see how the prototype works and gives you some results which you can use then on the reporting and planning new zones on different scales. You can more detailed zoning or then larger areas. All works and it's able to calculate. Here is you can see a larger area like this kind of larger planning. But I move to the next slide. This project, it's in 3 phases, and now we have entered to phase 1. So now we work closely with interested procureur cities in this project, at least Amsterdam and Ghent. So we work with them and just to understand what kind of issues they have with zoning. Cities have different issues, of course, that they want to measure. So in Finland, preventing deforestation is one of the main issues, but that's not necessarily the case in Amsterdam. So we will work with them to understand what metrics they need. But it can be reforestation, it can be urban green. I think urban green is important in almost every city. So planning that better, and flood prevention, and many, many others. This can be scaled to many indicators. And we are going through the available ground root data from the city, from those nations, and also applying the AI and satellite data to make it comprehensive. And this is the phase 1 is making a very good plan, and then phase 2 is to implement this plan. And we are, of course, if you have ideas or comments, you can always, even in now, just contact Avoin and Avoin Map, so we can know about your needs. Here is the last slide. So we have specific expertise on open source. Avoin actually means open. So we build our solution on open source basis because we believe that we know that it improves the transparency, and it also allows us to work with the global community of software developers and AI specialists all over the world, which helps to make like a more powerful solutions. And our tool is scalable and interactive. The user friendliness is one of our priorities. And in Finland, we have done prototyping with cities and our Ministry of Agriculture and Forestry. And we have built a team over these years which combines modern software with cutting-edge science. So we always work with the scientific institutions when possible, because we want to be on top of the latest developments and not only think that our own team holds all the latest knowledge. So that's working really well. And we have done 8+ EU projects. So it's some experience already how to successfully complete EU projects and make a good output. This is it. Thank you very much.
Okay, thank you. So nice and short, but I think you showed us as well what the tool is capable of, which was nice to see a bit of a preview. So thank you for this. Yeah. So, all right, then our next presenter will be David. I think if I have, I haven't mixed up the order.
Oh no, I'm happy to go now if you want.
Yeah, or was it Jeroen? I'm not quite sure, but yeah, if you don't mind, you go first and then Jeroen. Sorry if I mix it up.
No worries. Okay, is this all good? Can you see?
Yeah.
Okay, great. Hi everyone, thanks for coming to the presentations. My name is David Burge. I'm the head or director of computation at org. I'm going to present UMIS, the Urban Movement Intelligence System, today, and I think it's worth just pointing out that we are a very early stage. We saw a gap in the market that no one was filling, and we decided that we would love to fill it. So we're really, phase 1 of our company or our project here. Give a little bit of information on our company. So we're a multi-scalar, multidisciplinary spatial design firm. We're really a consultancy. We have typical architecture, urban design, urban planning, but our specialty is really building custom analysis, custom tools for cities that have specific problems that they're trying to address. And so as a part of that, we bring in geospatial analysis, we bring in agile team building, So we're very good at mixing in-house experts with and out-of-house experts or consulting groups. And we also have a lot of experience with stakeholder engagement because, you know, when you're dealing with very complex problems, you know, you need to really be responsive to cities. And then we have a track record of designing, developing, and applying really novel computational models to real projects. And that's exactly what this is, in our opinion. And so we've done this 3 or 4 times, and I'll show some of those at the end. I won't go through the team members. You know, myself, I'm the director. Lucas Diamant is working on this as well with me, kind of full time. He's our lead geospatial analyst. He's probably on the calls. He should be on the call, and so he can maybe pop his head in. And then also we have our co-founders and many partners who are very engaged with this project in the background. So answering the question of what problem are we solving, we're solving kind of, there's many levels to look at this. So we're going to talk more later about, you know, very specific challenges that we can help address. But really the fundamental problem we're solving is a lack of a high quality movement data for cities. And so what happens, oh, I'm trying to hide this. So what happens as a result of this is that cities just don't have a good enough understanding of where people are moving, when they're moving, and how they're moving. This is starting to get solved somewhat with sensors, but there's still some gaps that we'll see. And this is kind of just a matrix of the types of movement data you can get. The traditional travel survey, which, you know, people hand out to, you know, people fill out, you know, where they're moving, when they're moving, how they're doing that. That's kind of how demand matrices were built for many, many years, the last kind of 50 years. Really, ultimately, that is such a low sample size, both in terms of time sample, but also travel sample, that we're moving beyond that. And that's kind of how cities have planned their city, kind of planned everything around transportation historically. So like I mentioned, these counters are definitely helping, where you add sensors, you know, maybe 15, 20 sensors around a city. That's a very good start, but really that also has a lot of gaps in it. So you can see really the only way to get all of the information you'd like about movement, the use intensity, the path people are taking, the speed, you know, whether people are loitering or staying in certain areas, and also full coverage over multiple years with a fairly high travel sample, you know, Galileo or GPS data. That's really the only way to get it. And so why does this matter? Really, I think we know fundamentally that cities are, you know, are really at the core, just kind of complex objects that allow us to access things that we want: housing, jobs, you know, everything we do in our life requires us to move through the city. And so when we have suboptimal planning around that movement, it leads to all sorts of problems, right? So we have spaces that are either underutilized or overutilized. We have intersections and paths that are unsafe. You know, our emergency response plans are less informed. We don't know exactly how people are going to move during, you know, emergency events. Real estate values are lower, retail sales are lower, tax revenues are lower. Really, everything becomes more costly, less efficient. You know, we spend more time traveling than we need to. Also, we have higher emissions, right? We have more congestion. People aren't walking or biking or have, you know, using transit as much. There's a lot of proof in papers. This is one that I'm showing at the bottom, that if you provide high quality transit systems, people prefer to use them, right? So it's really just the lack of ability to design these. And obviously they're very expensive. So that's certainly understandable. And then ultimately also we have worse human health outcomes, right? So from the emissions, from the congestion, but also from a lack of active mobility. So our approach to solving this, like I said, we're very early stage. So we're trying to build kind of from this bottom up, like this inverted triangle, where we start with the movement data. We analyze that movement data to extract as much information from that as possible, but also to create a very flexible framework so that we can extract all the types of information we need to analyze multiple scenarios or to apply that movement data to multiple problems. And then above that, we'll integrate the movement data with other data, whether that's urban space planning data or transportation network data or environmental data. And then from there, we can start to build out end user applications, whether that's for mobility planning, space planning, you know, all of these things. There's really an almost infinite amount of applications of the data. So we're trying to take this approach where we don't want to, we want to build this kind of upward funnel so that we do these more core fundamental activities, you know, once, and then we start to build on top of that. So the first step is really processing the raw movement data. And that can lead to three kind of fundamental outcomes. One, we can do an edge analysis where we can just show how much activity at any given time during the day or week or year there, where is activity along edges and the transportation network. So where are people walking, biking, driving, where are they using transit? We can also, with a lot of the data, we can extract very high quality understanding of the path. So what mode are people using? Where are they going? When are they switching between modes? Maybe these black dots could represent places where people are stopping, whether to go to a cafe or a park, things like that. So we can get extremely high resolution and understanding of the types of paths people are taking through the city. This is really fairly novel. It's within the last couple of years that people are starting to look at this. And then we can also do a much more high level kind of area or zone analysis. And then with that zone analysis or with the edge analysis as well, we can start looking at patterns. So this is the second phase, doing the movement analysis, looking at patterns of behavior, patterns of activity, and then anomalies. So we can look at, let's say, the difference between an average winter weekday and an average winter weekend, right? We've already started seeing very clear patterns in movement, which you would expect. Obviously, people travel differently on weekdays and weekends. We can also take one of these subsets and we can start to look at the deviations, right? What's the difference between movement over this entire, over all weekends in the winter? And then what that also leads very clearly to questions of, why would movement be different in these certain areas? What's causing this deviation? And that can then lead to kind of trigger the more specific analysis of understanding what's happening, what's causing these changes in movement. So that's where we get into the step 3, which is integrating the movement analysis with a conditional analysis. I know this is very, very high level, very vague. Part of this is because we are also beginning this, but also part of it is because this is such a novel tool. We kind of want to protect IP at this point. We don't want people to, we want to get ahead of people as much as we can to offer kind of a unique product to people. So really correlating movement changes in movement, anomalies in movement with changes in either environmental conditions or spatial conditions. From there, we can then deliver the actual insights. And I am skipping this kind of middle step, which is, looking at those very clear conclusions. So I understand this is very high level, and I apologize, but that's just where we're at this point. So we can, because we're a spatial consulting firm, we can really deliver these actual insights across a broad range of options. We can either produce what we call an investment catalog. We can really just prioritize the action items. So you should put a bike path here, or you should consider extending a tram line or a bus line here and here to solve one of these mobility problems, or you should develop, let's say, a safe emergency passage in this sector of the city because this is where people need to leave, right? Things like that. We can just really rank order specific actions. We can also integrate that with risk analysis, cost analysis, things that org does also as a consulting firm. We can also just deliver process data layers and let the cities kind of use that, deliver that to the cities, and they can analyze that themselves. So kind of a halfway between. And then we can also give this data as a kind of explorable data environment where they can scrub through the data and we can sort of work together to investigate what these patterns of movement are telling us. I'll start picking up the pace a little bit. So in terms of space data, we're using really all 3 types of space data. We're using the Galileo satellites to give us the location data. We're using Sentinel 3 and 5 satellites to give us things like NDVI and surface temperature to correlate with movement. And then also high resolution satellite data, probably not coming from Sentinel, but we can also use this to investigate what's happening, right? When we look at anomalies, we can then look specifically at the urban features to start to detect what's happening or why things are happening. In terms of end users and benefits, again, there's so many. We haven't really honed in yet. We would like to develop this product in a way that we can hit all of these if a city wants. So just some examples, we can optimize transit networks, mobility networks. We can improve the routing, show where there should be connections, gaps in the network that people really would like to use given the movement patterns. We can also...
1 minute, David. Yeah.
Sorry?
1 more minute, David.
1 more minute, okay. And then, so city plan, I think one huge potential impact of this is we can measure the impact of new development infrastructure. So we can track changes in movement from before and after things are implemented in a city. So this really lets cities measure the actual impact of things that are happening. How is our approach novel and competitive? The technical solution, like I said, is novel. We're not aware of anybody else that's trying to fill this. There are companies that fill this need for businesses. They process this data and they apply it to, let's say, understanding real estate values, or where should you locate a business, or where's foot traffic. But we haven't seen a company that's doing this for city planning. And if you're aware of any companies, please let us know. We would love to understand the space of this this kind of analysis world. And then lastly, another thing that gives us competitive edge is our multidisciplinary team. We build our team through the phases. It grows or contracts based on what we need. And then lastly, we have experience doing this. We've done this 3 or 4 times with other types of content. So, okay, so I went over a little bit.
Brilliant, David, thank you. So much appreciated. Right, now we've got Jerome.
Okay. So, hello, good afternoon. Thank you for joining. I'm Jeroen from Geo Solutions, and I'm here to introduce our solution FlowDT, which is a mobility solution. So, FlowDT is a digital twin platform that helps cities to make smarter, more sustainable mobility decisions. And at Geo Solutions, a consultancy firm specialized in GeoICT, we've combined our expertise in geospatial intelligence and mobility to create a solution that fuses environmental and traffic data into a single and strategic planning tool for cities. So, wait, I can't. Okay. Why do we need such a tool? So urban mobility is under pressure. Cities have problems with congestion, poor air quality, and inefficient use of public space. These issues are connected, but aren't often considered together. So they need an integrated solution. So traditional planning approaches often separate mobility from environmental concerns, and that's why a system is needed that provides city authorities with evidence-based and data-driven tools to design resilient transport strategies. At the moment, many city departments work in silos, so the planning is often reactive, based on outdated or static data. There's limited ability to fuse or correlate information across domains, so that can range from traffic flow, pollution levels, and infrastructure changes. It's all there, but it's not connected. The result is that we have a fragmented insight or view of our city, and we miss opportunities to intervene early and coordinate effectively. FlowDT is designed to specifically break down these silos and deliver a fast and integrated intelligence tool that supports strategic urban planning and actions. So FlowDT is a fusion engine that combines satellite data, floating car data, high resolution imagery, and sensor feeds from the city into one digital twin. What's so powerful about this is that we develop macro to micro capabilities. So we can, for instance, show how nitrogen dioxide concentrations citywide from Sentinel-5 are affected or are impacted by specific congestion patterns in specific neighborhoods of your city. So really from urban to street level, we can generate. With machine learning, we are capable of providing trends, anomalies, and correlation analysis. And finally, and then most importantly probably, is that we provide with FlowDT planners a tool to simulate scenarios based on data-driven observations. So it's really based on observations. You can simulate, for instance, how a low emission zone implementation in your city or changes in transit flow will impact the air quality and so on. And you can really analyze the results before implementing and taking action on that part. In day-to-day operations, so FlowDT enhances situational awareness by offering a shared view across departments, which is at the moment lacking. Whether it's a road closure, a peak pollution event, the platform will help you assess what's happening and why. So, for example, if pollution is rising in a certain area of your city, you can link it to traffic volume, and that can then trigger an alert on which you can act on. We also track performance, so how accurate are the alerts, how fast is the response, and how many departments are using the insights. On the long term, the value really starts from the Earth observation data. So we use Sentinel-5 and CAMS to provide daily validated air quality data. This is then used to track the nitrogen dioxide concentrations and the particle matter trends, identify pollution hotspots, and evaluate policy impacts over time. This allows cities to plan investments based on data-driven evidence. So, for instance, as an example I used before, if you have a new low emission zone or you reroute somewhere, you can assess the impacts on both air quality and traffic on the same time. Very high resolution imagery, for instance, sorry if I butchered it, from Pleiades. Let's assess parking density, green space use, and urban space recovery opportunities. So, in short, our Earth observation data gives us kind of an environmental insights or a camera that allows us to transform FlowDT into a strategic and climate smart planning tool. So who will be our users? Urban planners can use it to forecast long-term changes in mobility and space use. Transport operators can benefit it through better or more accurate near real-time traffic data and pollution data. Environmental authorities can use it to assess the link between emissions and mobility. But also, more importantly, we want to stress that we also want to have citizens as kind of an end user, which is then through the dissemination platform, where they can explore the impact of certain mobility scenarios in their neighborhoods, which then increases the transparency and builds trust and support for the city policy. So, about the space data, I've touched this a little bit already. So we use Sentinel-5 to let us map the nitrogen dioxide concentrations daily across the entire urban area. And CAMS is then used to enhance this with validated air quality baselines, forecasts, and reanalysis data. Very high resolution imagery can help us monitoring parking dynamics and spatial use in great detail. And then finally, Galileo could eventually even provide lane level precision for connected vehicle data. Altogether, these space assets combined with floating car data enables FlowDT to connect mobility with the environment, and that is key, according to us, to more precise planning. So what sets us apart? So at Geo Solutions, we don't just deliver data, we co-create real solutions with cities. We are a consultancy firm located in Belgium that has worked with for almost 20 years already with a lot of local authorities across Europe. So we understand the complexity and also the day-to-day operations that you face. FlowDT is built to deliver policy-ready insights, not just maps or metrics. So our macro to micro approach means that you can go from citywide pollution patterns to really specific street level congestion information and triggers in just a few clicks. And our co-creation approach ensures that tools that we build are actually usable, adaptable, and aligned with your workflows. And then, so finally, to summarize, FlowDT is a fusion-powered digital twin that combines Copernicus Earth observation data with traffic and sensor data. Then it transforms it into insights that can support cities for better planning and better public outcomes. Whether it's reducing congestion, improving air quality, or regaining green spaces, FlowDT supports cities in making decisions that are smarter, faster, and more sustainable. And it does it in a way that it also brings citizens along for the journey. So it's a scalable solution ready to serve a wide range of European cities. And thank you for your attention.
Brilliant. Okay, thank you, Sharon. We run just in time. So now we've got one more talk by Roland.
Roland, yes.
Yeah, Roland, please could you share your screen in, and then after that go to the film. Yeah, we can't see you yet, I think.
Yeah, now it should be fine.
Yeah, hang on. Yes, but if you share also your camera, it would be great so people can have a focus. Would you be able to share your camera?
My camera is shared, isn't it?
I don't know. Maybe it is. Sorry, maybe I can't see it, but oh yeah, it is. Perfect. Sorry.
Okay.
No, it's yours. Thank you.
Okay, so I'm Roland Nemeth from let's go back again, from Urban Energy Scan, and we are a team of the consortium consists of Paulinyi and Partners Innovations, Fraunhofer Institute, and EnviroSense. Paulinyi and Partners is an architectural and urban design group, and we are the innovation department within that. Fraunhofer is one of the premier research and development and applied research institutes in Germany, and EnviroSense is an Earth observation company based in Hungary, and we've developed together the Heatscape Resolve Urban Heat Island Effect service last year within the frameworks of ESA business applications. So this is our team. And why Urban Energy Scan matters is the following. So this is a national and international level problem and the EU level problem as well, but it boils down to the cities themselves, because 30% of the energy consumption is due to the buildings, and 36% of the CO2 emissions within the EU is also attributable to the building constructions, and 35% of the buildings are over 50 years old, and 75% of the building stock is energy inefficient. So that means that the whole European building sector is quite rife for change. And of course, since cities are the main area of construction most of the time, and reconstruction and rehabilitation of buildings, it makes sense to focus on them. And since we are facing as an architectural and innovation practice very often the task of advising cities to how to develop new quarters and how to make new real estate investment zonings, and also assess the potential retrofit of existing buildings. We have seen this gap in developing a service which can provide on a large scale with the use of Earth observation data this ability for cities to gauge their building stock and to get a good picture about what greenhouse gas emissions the buildings have, what energy use for different types of energy they are using, and assess with that what the development options could be. So our solution for this problem is the Urban Energy Scan, which enables cities to use Earth observation data combined with simulation building performance energy simulation engines, and simulate first of all the building stock that they already have and might not have the complete picture and data about the performance of the whole building stock, and simulate energy policy impacts depending on or the preference of the cities itself, if they would like to subsidize retrofitting of certain quarters, or if they would like to create new quarters, maybe on the outskirts, and see the impact on the existing energy infrastructure of these new buildings. This is something that the urban energy scan can do, and why this is a hard task is because just because of the sheer volume of the buildings and the different attributes that are needed for energy performance assessment of buildings. And this is where we are employing the satellite Earth observation data to gauge as much data about the buildings themselves, mainly, of course, the envelope, what is already visible. So the outer envelope of the building, we are assessing through Earth observation and AI-based trained data, so that we can cross-reference that data with, for instance, the age of the construction of the building, and also the typology of a certain building. And then with that, we can estimate quite well what building materials this building has used, and of course, based on the Earth observation, also to see what kind of cooling or heating system this building may have. And based on that, we can do the energy assessment of individual buildings, but also of the larger quarters and districts. And on top of that, we also add the urban heat island effect simulation, because, of course, when cities are densifying, it changes the urban heat island effect, and it adds to the temperature of the overall temperature of the area. And that needs to be incorporated into large-scale building performance or city energy performance simulations. So who benefits from this? Municipalities, because they can assess the energy consumption of their building stock, as I mentioned, and they can get a good support for new developments. So they can assess basically what impact on their existing, for instance, energy infrastructure, let's say electricity infrastructure, a new quarter will have that will demand a certain amount of electricity at peak hours, for instance, during the summer when the air conditionings are running hot, and also to assess retrofit actions or energy communities that they may establish within one city quarter. For residents who are focusing mainly on their own building, probably, the estimation of their own building and how the community of that building can think about enhancing the energy efficiency of their own building. For utilities and developers, the energy consumption and the potential energy consumption of new developments that they are planning to place next to a new city, or if they would like to redevelop a quarter to see what kind of energy savings they can achieve by retrofitting existing quarters is the main benefit. So the innovativeness is the combination of Earth observation and building energy assessment, because even though there are a lot of different simulation engines, also urban, but also individual buildings performance simulation engines, it's extremely time consuming to get all the data for each individual building and then to assess each building one by one or by small groups. And Earth observation and machine learning can help there, because once you can detect the envelope of a building, and once you know what typologies exist in a certain climatic area, you can infer from that what construction layers that building has, what insulation values that building probably has, and based on that, you can get a really close calculation on the energy impact of the building. So our workflow is to first define well, at least in the phase 1 here, to define the challenge, what the buyers group cities have in terms of building energy consumption. Is it rather, rather the retrofits that they are looking for, or is it rather the new quarters, or to estimate the existing building stock? And use smart satellite data processing so that we can see the envelope, assess the envelope of these buildings in mass, to get a good picture of the overall city-wide building energy consumption. And layer on top of that the urban heat island simulation based on the density of the quarters which are being assessed, and then run the simulation, the energy simulation based on those data points. And once we have that, we can do the integrated spatial insights, integrate this into digital urban twins of the cities. Or we can make decision support dashboards where cities can basically assess what changes in their energy policy or their infrastructure redevelopments may have on their current consumption, and based on that can make the decision if to go ahead with this or with another retrofitting scenario, or if they would like to prefer a more dense quarter to be built or a less dense, or what kind of a load this will place on their existing infrastructure. And that was Urban Energy Scan. And thank you very much for the attention.
Thanks, Roland. Just bang on time. So brilliant. Thank you. Really. Okay, so I think this has concluded our 5 presentations, and we're now sort of coming to the panel discussion. So can I sort of ask each of the presenters to come back live online? So turn on the camera, including you, Roland, would be great.
Yeah.
Perfect. Yeah, everyone. Perfect. But everyone here? Yeah, do we? Yeah, now everyone is here. Perfect. Thank you, guys. Yeah, so it was actually, this is our 4th, obviously, webinar out of so basically the final one. And the presentations today were, I guess, for me, the most diverse, not in terms of speaker genders, but at least in terms of the content, the style, and also maturity levels of solutions. So that's quite nice. So that gives us a lot of also like good starting points for our conversation here. So starting off maybe with we were the first speaker, and obviously you had a very polished presentation, right, of something that is everything is ready, just come to us. Obviously this is an innovation project still, and I'm quite curious to see if you've got everything developed, or what are you actually developing in this project. So can you explain us a little bit more? I mean, obviously you've got a nice infrastructure and tool already, but what's the sort of added value that you're creating in this project?
Yeah, sure. So yes, we already have developed a solution for a city to monitor in real time their CO2 emissions, but for the moment it relies massively on sensors, ground sensors. And you can imagine for cities, this is a logistic nightmare, when you want to install this kind of system in a middle-sized city, and you need around 100 sensors to do it. It's a nightmare for cities. So what we are doing now with the SPACE4Cities program is actually switching from a system that relies on ground sensors to do the measurements and use satellite imagery to calibrate the system, to a new system that relies on satellite imagery to do the measurements and relies on ground sensor to calibrate the system. That will allow us to reduce dramatically the number of ground sensors that we need to install in the city, and therefore accelerate the duplication of the deployment in any new city.
Okay, that's very clear. Thank you. Yeah, so now I understand it. makes total sense, right? Also, you obviously talked a little bit about your zoning tool and obviously helping basically people to manage or plan those zones better. I'm not an urban planner, so for me, the concept of zones is not as clear. Can you just explain me what's the purpose of thinking about the zones, and what sort of change can you then suddenly enable?
Yes. I do my best to answer. Well, we have been working in the prototype phase, obviously, with some Finnish zoning officers in the cities. Almost all cities have such employees who are planning the new areas, and they have their own tool, geographical information systems, where they make the drawings. And so we are not necessarily competing with those tools that they are already using, but those tools lack like the environmental impact assessment. So they can bring their zones to our web tool, and then they can calculate. And that's what was lacking. And it's also quite a new thing. Like 5 years ago, maybe nobody was even thinking that we should analyze what's the impact to climate or biodiversity. But now EU is putting pressure that you really need to report this, and you need to think about it already when planning. So this is what we aim to help these professionals.
No, very clear. Thank you. Now over to David. I think obviously you have kind of zoned in initially really on sort of more fine-grained mobility data, right? And this is sort of like what certainly this sort of data can enable and drive, and there are endless opportunities to present it, right? So following that, but I guess the key sort of thing that you want is accessing this sort of mobility data, right? And then try to abstract it into models so it can be used to solve different challenges, right? Which of the challenges do you see currently as sort of the one to focus on first?
Yeah, it's a very good question. Obviously, we've been talking with Amsterdam, who's our partner on this. I think honestly, in the next week or two, we're going to figure out what we think are the maybe 2 to 4 specific end user benefits that we can apply this data to quickly, right, to get some insights as a proof of concept. So the answer to the question, I think probably analyzing the efficiency of mobility networks is one. Looking at where are people moving to and from, and are let's say especially the bike networks, are the bike networks efficient, or are there linkages that could be added that would significantly improve accessibility or the speed of movement, also maybe even walking paths. So that would be one use. I think another is for I don't know if we'll be able to do this right now in phase 1, but I think understanding the impact of projects, from before to after. So if you add a park or if you add new infrastructure, actually measuring the impact on movement, I think that could be very, very helpful for cities to really track and prove the actual impacts of infrastructure, urban space planning, public space planning. And then, there's some other opportunities in terms of like resilience planning, understanding. I think a very obvious one is understanding exactly at what temperature or human comfort levels people start to reduce movement patterns, walking, biking, but also understanding where movement is inelastic, right? So we know in the United States from research that some communities just don't have the option of driving or taking transit, right? They really have to continue using walking or biking. And so we can really pinpoint, okay, what communities and what areas are going to be most at risk for overheating, during a heat wave, something like that. So that's the kind of three options. Yeah, but
cool. Yeah, understood. And capturing this data, obviously, you said you rely on. So for instance, I know like from UK cities, as an example, actually the way they access currently movement data is, for instance, by working together with mobile operators.
Yeah.
Who are actually creating data products based on people movement data of the phones they carry, right?
Yep.
So what's the difference that you are doing now compared to them, or is this just one type of data source that you consider?
I would say no. It's roughly the same thing, the same data set. I think, as I mentioned, I think the difference is our application to urban planning operations. Whereas there's a lot of examples in papers showing either test cases or really for-profit companies using this data. So I think it's the application of the data that's unique.
But basically, I guess in the sort of pilots, were you thinking of acquiring this data by, accessing phones of people or giving them trackers, or was it ideally purchasing?
Sorry. No. You can buy the data. There's providers, right? Yeah. They gather the data, they process it, and then they sell it onwards.
Right.
So yeah, you can, the data is available. We're working with the data right now, right?
Understood. Okay.
Yeah,
Okay. Thank you. Then, Jeroen, you also had some interesting conversation around like the sort of low emission zone planning, right? And also like how you could use mobility data and also then impact data on from pollution to then understand what's the impact, what if scenarios and stuff like this, right? So explain a little bit more like, this interplay and how you envision that to happen. Like, yeah.
Okay. So our core is the digital twin. So we integrate all the EO data into it, which is then mainly the pollution data and the floating car data. Based on that digital twin, you can then really simulate on like say if we block this street, this has this impact on traffic. But in case of a lower emission zone, even, yeah, you can really say like if we make this section of the city unavailable for cars that emit so much carbon dioxide or nitrogen, then that can be taken into account in the simulation to see how much emissions are created by these cars, how much were before that percentage. For instance, we're still a bit conceptual, but that percentage then can be taken into account of change, and then we can also see how that can impact based on simulations, but also based on monitoring. If you see for like day, night, what's the difference between the concentrations, we can have kind of an idea also what the cars are emitting and contributing to the urban environment. So based on that, the interplay between mobility and environmental data is created.
Yeah, I guess the challenge is as well that it's not only cars who are emitting, but it could be factories or other things, right? And you need to sort of attribute your emission sources a little bit more. I guess something that.
So that's really indeed that's something that we still need to look into a bit to distinguish between all the emitters.
Exactly. And also, how do you actually consider then also impact on traffic again, right? Obviously, you say fine, I cut off the street, and I'm sure it's going to be cleaner. But then this rerouting of traffic might then lead to congestions and also pollution in other areas, right? Or more pollutions. But does your simulation consider that as well, right? So what would be the impact on the mobility?
Yeah, so it's not like if this street, you can look at the street level, but you can also zoom out to the greater picture, the bigger picture.
Okay, so you also feed then, you change your simulation model for the traffic part as well, right? So it's both not only air quality simulation, but also traffic simulation that you do hand in hand.
Yes.
Correct. Okay.
And that's based, so part of Geo Solutions, we're one firm, but we have sister companies. We are with a lot of expertise with partnerships with TomTom to generate like traffic insights and so on, and smart cameras and so on. So.
Brilliant. Cool. Excellent. And then for Roland, one question, and then I think we'll hand over to the audience. I think I was quite fascinated, right? So the sort of how can you just by looking at the shape of a building understand its energy consumption, right? So I think it's obviously okay. You introduce some references like you need to know the age and stuff like this. So you're actually already accessing, I guess, some ground-based data, maybe some existing energy certificates maybe as well or not, but
it's a good point. It's a good point.
So like magic to me. Yeah, just to look at the shape and then knowing it could be like 10 stories or 1 story. It could be, you know what I mean? It could be different building materials.
Yeah, it's definitely not an easy proposition. So there are, of course, off-nadir imageries as well, which you can use then for estimation the height, or you can use synthetic aperture radar to get the height of the building itself. So it's more like a data layering exercise. And based on that, if you know the building typologies, and most of us here are architects. I mean, at least at Paulinyi and Partners Innovations, we do regularly energy assessment of buildings. Sooner or later, you realize that very often the same typologies are coming again and again, and And in one particular decade, most of the buildings are constructed in a very similar way. Office buildings are constructed towards a very similar standard in one decade and then the next decade. And once you get the age and once you get the outer layer and the use type and of course like the shape of the building, you can infer a lot of information based on that if you know how most of the time those buildings were constructed. And of course, the Earth observation data is a huge help in that because otherwise you would not be able to do that in scale. You would have to assess each building one by one, and this helps. But of course, it's part of a big data fusion exercise. Getting the permit dates of each building, for instance, from building land repositories, and also. If you know the shape, I mean the outline shape of the building itself, you can get the volume by using also the synthetic aperture radar building height properties. If you know the type of the building, you can infer, for instance, the building window to wall ratio, which is part of the solar gain of the building, which is one.
Yeah, understood. So there are models you can develop. Yeah,
exactly.
Yeah. Okay.
But you can of course always fall back to a lot of defaults because if you know, like I said, the age of the building, very often at a certain age, buildings had a similar window to wall ratio in a certain city or in a climate zone. And depending on the age of the building, you can fall back on a lot of defaults if you don't have the data for some parts of a country. So that's.
Brilliant. Thank you. Yeah, no, I think I can now better imagine how this might work. Okay, I think if at this stage I would like to maybe ask Ari to come on. I think Ari is basically a colleague from the project as well, who will help me a bit go through the questions posted in the chat, and I think there were quite a few. So.
Yes, hello everyone, and thank you for very active question submissions. So I collected them now and I have like mixed them a bit together to make it easier, and we can go one supplier at a time. We can start from the EverImpact. So you have received around multiple questions, but I will back this up a little bit. The questions are mostly about your data sources and satellite data sources specifically. So that the questions are asking like what kind of satellite data sources are you using, and are they different from traditional greenhouse gas inventories, and are you tracking direct emissions, and how do you take the balancing of emissions into account in your system? There was also like ask a question that like how can you achieve the hourly temporal resolution? There's quite a lot of questions that I hope you can give a comprehensive answer.
Yeah, I'll try to. Let's start with the first question that I see here, like measuring only direct emission of GHG. That's a very good question because it's raised a point that always bugged in my mind ever since I was a kid. So the question is, how is it that we use a scope system to account for carbon? Every single ton of CO2 which is released into the atmosphere happens somewhere, at a specific moment. Any scope 3 emission for one entity is actually a scope 1 emission for someone else. So when you have the ambition that you want to measure every direct emission everywhere in the world, you actually are on a system which is scope 3. And this is only when you do that that you really reflect the reality. Scope emissions are a way to allocate accountability and ownership of CO2. That's okay, but it shouldn't be done at the layer of the measurements. What we need is scope 3 method. We need to measure direct emission worldwide, and then we had statistical models on the top of this to this highly accurate data to fit in the standardized way to account for CO2 emissions. On the question about the satellite data that we use, yes, we use CO2 measurement from satellites. You have 2 missions from the NASA. which are OCO2 and OCO3. OCO3 is the same instrument that OCO2, but it is actually installed on the space the space station, the International Space Station. This is for the measurement of the CO2 concentration. This is, in my knowledge, the only two missions that no, not the only, because there is a Japanese one as well. Then we need to understand that there is a huge correlation between the land use pattern and the actual emissions. So once you have the land use pattern using classical satellite data like Sentinel-2, Sentinel-1, if you want to have the height of the buildings, as has been said before, you can generate a kind of 3D digital twin of the city, and you can deploy a computational fluid dynamics model to try to calculate how the concentration of CO2 that your ground sensors and your satellite sensors measure at a specific time can be translated into a flux of emissions. You just have to go back in time with the CFD model. The difference on traditional. So yes, it is different from traditional inventories. It's actually, and I think it answered to another question, which was, does it encompass all the emission of my city? So yes, because actually what we do is a territorial-based emission monitoring system. So everything that we're able to observe, to measure, it is included.
I think the last question was just about the every hour, right? So if you can say how can you do this every hour, and then we can move on.
Yeah. Basically, what gives us the real-time capacity is the ground sensor. The ground sensor is measuring CO2 concentration even every 30 seconds. Every 30 seconds, we do a kind of average every 10 minutes, and we receive the data every 10 minutes. So that's how we achieve the early capability. Now, as I said at the beginning, at the first question from Alex, we are switching from this ground sensor base to a satellite base. This is where the challenge comes, because how with 1 or 2 or even 3 satellite observation in a day can you achieve this kind of hourly revisits thanks to a limited number of ground sensors? This is where the new models on AI come from.
Okay, so these are basically estimations, right? But they're calibrated by the satellite in the end, right? In this case, yeah.
I think the main thing is between two satellite observation, you can't do anything else than estimating. But after you have a new observation, you can retro back to your previous estimation and improve it. So it's just about what is the timeliness of the data and when you can re-improve and recalibrate every time your system.
Brilliant. Thank you. Maybe the next one, Ari. Yeah. So thank you for the very extensive.
Yeah, thank you, Say. You had quite a set of questions aimed at you. But okay, let's move next to the Avoin Map and their zoning impact mapper solution. So yeah, these questions aimed at you are mainly about the solution itself. And so the first question is about the zones that you show in your solution. So how they are decided and selected, and what is kind of their size level? Are they on a land use assignment level or building level? And do they allow use of polygon layers or other geographic definitions that you can use in GIS software, for example? And then the last question is about what kind of carbon data is it outputting your solution?
Thank you. I'm trying to find the first question from the chat. Is it in the chat?
Yes. I was compiling them a little bit.
Maybe Ari just go one by one. Otherwise, I think it's a bit tricky.
Yeah. So I guess you can first describe the zones. How do you decide them in your solution, and what kind of editing does it allow with polygons, and how detailed are they?
It has full editing. You can draw even, you don't need to have any zones. You can start drawing by your own. It has a drawing tool, and you can add as many polygons as you want in different sizes. But when you bring, zoning officers usually use a software called AutoCAD and QGIS. So you can bring any format output from those softwares to our web software as well. So then you get the file that you already have created. And then if you have any issues, like there was something like overlapping issues of data when you have the same data into two different places and you want to integrate it, we haven't developed a solution for that, but there are those existing tools that already have solutions for that. So then you have to do the manual work that you are used to do anyhow, and then bring the area that you want to analyze, the zone that you want to analyze, to our zoning impact mapper, and then you get the environmental assessment. I hope this was good.
Yes, and so what kind of carbon data does it output? That was the last question.
Yes, this is important question, which I could have already elaborated a bit more during the presentation, but now it's a good time. So the primary carbon data that we currently, and also in the phase 2, I think we focus mainly, is soil and vegetation carbon. So that was a challenge in Finland, especially, that to know how much carbon is removed from the soil when we are looking at the current situation, and we have an algorithm that is predicting what's going to happen in the next 70 years when you have trees and parks and vegetation and the soil, how it's going to develop. It's going to have carbon sequestration. And then when you bring buildings or some other types, factories, industrial areas, streets and railroads, you want to know what's happening to the carbon in the soil and vegetation. And then we compare this to the current situation, and we have a estimate of how will the new land use affect. And also, let's say that you still put a park, we still account for the carbon sequestration. If you you replace a forest with a park, of course you lose quite a lot of carbon, but still the park will have a certain level of carbon sequestration, and we will account for that. But we can consider in the phase 2 and especially phase 3, we can add more.
Thank you. That's good. Maybe Ari, let's not do all questions for all speakers, but maybe just one each.
Yes. There's only one left. To my knowledge, I haven't seen any more. This is for Paulinyi and partners, Urban Energy Scan. And this is quite a direct question, which states, can you detect construction materials of the buildings using Earth observation data?
Yes, I partly answered it in the chat as well. So it's part of course, of the current development. It's one of the main points that we are addressing right now. One idea is to use machine learning trained super resolution Sentinel-2 data. But of course, we would like to extend it with off-nadir supporting mission imagery as well. But it's like part of the development which we are doing right now.
Yeah, excellent. Ari, so this was the last question from the chat, yeah?
Yes, there are no other questions.
Perfect. Yeah, then maybe just give also like a quick sort of show of hands around the people who are still around. Any other questions you might have, or you want to raise your hand and ask the speakers? Now is your chance. Okay, good. I think you were either very clear and people are satisfied, or I guess it's also getting a bit late in the day. But good, great, thank you. Okay, so I was actually also, I was thinking as well to sort of talk a little bit about still business model as well, that you think about the solution, but I know maybe I can ask this question, but very briefly. So maybe in 20 seconds or so, explain us a little bit what's sort of your business model, or that you consider, is it sort of software as a service, consulting, subscription? What do you offer to your customer as a business model? Yeah, let's start off with say.
So
briefly,
very briefly. Our business model is a SaaS, software as a service, subscription-based model. So there is three tiers. One which is free. You can access the data, and once we have deployed the solution worldwide, everyone will be able to look at his own data. The second one is where you start the subscription because you want to access to the data and extract the data into your own reporting system, etc. And the third one is, yes, still paid, but you will have the capability to add ground sensors in your area that you want to monitor to add in terms of accuracy to increase the accuracy of the system for the different reasons that we discussed just before.
Well, thank you. Nice one. Also, how does your zoning tool work in terms of business model?
Zoning Impact Mapper has a similar model in the sense that we also have a freemium, which allows even the smaller cities to use it, but it has a premium when you get all the full features of team features, and also adding cities might have some different data sets that they want to integrate, and it doesn't happen by snap of the finger, so it's included in the service with support. That's one. And then really quickly, the second one is that there seems to be industrial players and mines, airports, industrial areas that are creating some damage inevitably. They still need to zone areas, but they would like to compensate. So in the long run, we might create a marketplace where they report their impact. Cities might have some reserves, like they would like to create Natura zone, some protected area, so they get some funding from those who create bad impact compensated. But these two.
Thank you. It's innovative. Yeah. It's just I know. I guess David, you're still figuring out a bit how you're gonna want to charge. It's quite consulting driven currently, or?
Yeah, I think from experience with past products that we've developed, I think we start as a consulting service so we can also make sure we're delivering like really exactly what the city needs. I do think after we use this consulting method a couple of times and we see repeatable workflows that cities are clearly desiring, and we have the kind of workflows really tightened up, then I definitely would expect some sort of SaaS product or a quasi SaaS where we use the tools and you can hire us to run the tool, or you can run the tool, or some combination. But yeah, we're still pretty open-ended on that.
Cool. Pretty makes sense. Sharon, quickly.
So we will also be a SaaS solution, which allows us to provide a scalable and cloud-based platform. It allows for fast onboarding, fast development or deployment or installation, and we can update it as we need. For cities with more strict data governance requirements, we can also look into data as a service and then provide curated data, analytics, and APIs to provide them for the necessary data. But as our goal from the firm also is like to work together, this is all negotiable also with.
Brilliant, thank you. And Roland, finally, quickly, what is sort of your model that you envision?
Sure, it's very similar our approach as David's as well. Because first we would like to fine tune it as a service, and then proceed to make it a software as a service once the needs are fine tuned with the buyers group and the cities themselves. Once everything is really, exactly as the customers would like to have it, and since buildings are not popping up every minute here and there, we probably have a slower cycle of refreshes or of passes, which we need to do for cities, monthly or yearly. That needs to be decided.
Okay, brilliant. No, thank you. I guess it's all makes sense, and I would like obviously take this opportunity now to thank you all for the speakers to start with for being part of the session and sharing with us innovations that they are currently developing and also insights about even the business model. So that's much appreciated. And also thanks to the audience who stayed with us until the very end. I hope you could also walk away with some new inspirations to know a little bit about the future, what's coming, and what could be also useful for your city and region. And hope we can keep in touch with the project and potentially join us as well on some of the pilots that we will be running later. Okay, and yeah, I think that's all for now. We've reached the end of the session, and yeah, I wish you a pleasant rest of the day. Thank you. Bye-bye.
Thank you.